Multiverse as we know it in pop culture. Marvel media like Spider-Verse and Loki showcase the different ways writers will use this theory to their advantage. In Spider-Verse, the first movie introduced multiple Spider-Man converging into the protagonist's universe due to an antagonist tampering with dimensions. The sequel expanded on universe hopping, where devices allowed travel between universes and introduced canon events key occurrences. Spider-Man must face to prevent their universes from collapsing original timeline branch into multiple universes as the organization managing it evolved. In Loki, similar to canon events, anchor beings are essential individuals whose deaths destroy their universe. Additionally, Nexus events mark pivotal moments that cause timelines to diverge, creating entirely new universes. Everything Everywhere All at Once is also another example that uses their definition of the multiverse theory as a medium to communicate their storytelling via universe hopping. How it differs from actual theories. Obviously, actual theories are far more complex, abstract, and grounded in physics. What pop culture does is make it observable, as the multiverse theories are purely theoretical, with no empirical evidence yet. These theories rely on abstract mathematics, experimental data, and hypotheses such as the many worlds interpretation of quantum mechanics or cosmic inflation models. The pop culture rules governing these universes are fluid and tailored to the story. Accessibility is common, often via magical portals, advanced technology, or dimensional rips. Scientific universes, if they exist, may have radically different physical constants or laws of nature. For instance, gravity or electromagnetism might not behave the same way, potentially resulting in universes without stars, atoms, or life. The universes in scientific theories are entirely separate, meaning that even if they exist, we likely cannot interact with or even perceive them. Recent technologies like the Large Hadron Collider, or LHC, and the Hubble Space Telescope fueled multiverse theories like the string theory. Max tag marks 4 levels of parallel universes. A level 1 multiverse is the simplest type of multiverse with the least controversy. It hinges on the implication that space is infinite, which implies that there could be anything out there, including universes that are the same as ours. The thing is, there's a limit to how far out in space we can see because of our tech. So, in a level 1 multiverse, parallel universes just like ours exist, but they are simply too far for us to observe. Here, space isn't just infinite, it's constantly expanding. Forever. This is the theory of cosmic inflation. Sometimes, some parts of space will stop inflating and cause pockets called bubbles to form, each with their own level 1 multiverses inside that may have different physical properties. These bubbles are disconnected from one another because the space between them expands faster than one can travel through it. A level 3 multiverse isn't something far off into the distance, but happens all at once. It circles around the many worlds interpretation of quantum physics. But be not afraid. Simply put, the many worlds interpretation says that every possibility corresponds to its own universe. So, let's say I roll a die. There is a universe where it lands on 1, on 2, and so on, virtually making it so that the dice lands on all faces at the same time in different universes. Level 4 is where the chaos happens, and it gets a little more mathematical. In this multiverse, There are parallel universes where equations or laws of physics that don't usually make sense do. Unlike the last three levels, where there are some variations on laws, level 4 says that, seriously? Anything goes, even things like 1 plus 1 equals 5. Maybe there are universes shaped like Klein bottles or Mobius strips. Here in level 4, it's free game to be totally different. At first, thinking about the multiverse seems like a fantastical or useless feat. Why study something that seems so far away? Well, before you knock the thought down, consider that once upon a time, the concept of the Earth being round or the existence of atoms seemed ridiculous. Who knows? If our observable universe expands far enough, we just might be able to see our neighboring universes someday. Or maybe in another universe we already have.